Okay, hello everyone. Okay, hello everyone. So today, we would like to talk about the time complexity analysis of iterative algorithm. Okay. So what we will discuss about is first that we need to give you overview of what is the functions of time and what is the time complexity, and there's some method to to describe or to get the functions of time complexity. Okay, so the first is direct observation method, and the second one is the sum notation method. Okay, so okay, so in this course, of course, that we will elaborate the mathematical analysis of iterative or non-recursive algorithms for analyzing their time efficiency. Okay, so here there are three types of time complexities. The first one is the Tmax. Okay, so what is Tmax? Tmax in this one. Wait a minute. So comment. So what are Tmax? So the Tmax is the functions of time complexity of an algorithm which it needs maximum time. So that we can call that Tmax is the worst case. Okay, the worst case. So when the algorithm needs a minimum time, so then we can say that the algorithm have t minimum, so that this is the best case. Of course, that's the best case. And the t average is that it needs the average time. So what are those? What are those about this function? So let's see the previous example. Actually, we talk about the algorithm of searching. Okay, so look at here. So this is the algorithm of search. Search k number, the number k, into the array a, the size 1 until n. Okay, the size n. Okay, so then the question, if one iteration need 1 second of time, and how long this algorithm is executed. So for instance, that this one, yeah, this one is it needs to 1 second. Okay, so one loop need 1 second. Okay, one loop, one time loop need 1 second. Okay, so what do you think about it? How long this algorithm is executed? So of course that it's depend on how many loop. Okay, so depend on how many loop it will execute it, and how many loop is executed is also depend on the position of k, right? So look at here. So imagine that you have the a, you have number index 1, 2, and etc. until n. So then when the k is in these positions in the index 1, so that means the only this these operations will be executed once. Okay, and then it needs 1 second. Okay, meanwhile when k at in the index 2, so this syntax will execute it 2 times, and then of course that 2 times of 2 iterations, that mean 2 seconds, and etc. Okay, so that we can be analyzed something like this. And of course, yes, the answer is it depend on the positions. Depend on the positions. Where the position at the index 1, so it needs 1 second. In the second need 2 seconds, and etc. Okay. Okay. So then therefore, if it depends on the cases, so what we can make three cases in this example. First case is that we have we call that this is the best case when at k the position of k is in index 1. So then the algorithm is in 1 second. So then finally we will have tn. So the tn is equal to 1. And since that this is the best case, so we can write something like this: t minimum, sorry, is equal to 1. sorry, the function of n is equal to 1. So since that this is 1, so remember that 1 is in the big O of constant 1, okay? So since this is the constant. So this is the best case what we have. And the second case that when the position of k at the end of the array, for instance, that you have a, remember again, something like this, and this is the positions 1, 2, blah blah blah, and this is n. So where the position k in here, so what happened? So when the position is k, then of course that this function will be executed in n time. So it will be it need n seconds. Okay. So then what we have here, Tn is equal to n. So in other words, that we have T maximum. Okay, so this is since that this is the worst case. The worst case that the position of K is in the last array. Okay, so this is the n is equal to n. So this is the worst case. And the third one that the final one that we need to observe that what we can observe, what we observed previously that the time is depend on the position of k, right? So when in here when k is at the ai index, then the algorithm is in I second. Or we can write something like this. So when I equal 1, okay, so ai, when I equal 1, then this is in 1 second. When I equal 2, and it is 2 seconds, and etc. When I equal to n, and it needs n seconds. Okay. So what we have here, so that so we have 1, 2, 3, 4 until n. So then we need to get the average. Okay. So what is the average? So the average is 1 plus 2 plus etc. plus n divided by n. And finally, what we have in here, that this function is n time n plus 1 over 2, right? So over n, so something like this, n, and then finally we have, since this can be eliminated, so this is n plus 1 over 2. And this is the big O of n also. Okay, so this is the cases of the average. So generally, to for analyzing time efficiency in iterative algorithm, we have some steps. First, that decide on a parameter or parameters indicating an input size. Okay, and the second one that identify the algorithm's basic operations. So we need to define the basic operation of the algorithm. So it's such as where it's located in the inner or something like that. So check whether the number of time the basic operation is accurate depends only on the size of input. Of course, that it's if it is depend on, so some additional property, something like we can, if we can decide that the algorithm will get the worst case, average case, or maybe the best case. Okay. So something like the previous example in the search, we need to investigate that we have the worst case, average case, or the best case. Okay. And last one is set up a sum expressing number of time algorithm basic operation execute. Okay, using standard formula and etc. Okay, so we will direct. So in this lecture, in my lecture, I will introduce you the three methods actually. So this is not two, but this is three methods. And the first one is called direct observation method, and the second one is the sum notation method, and the third one is table construction method. So even that in this week's in this video, we just only talk about direction observation and the sum notation method. And the rest will be next week's. We talk about the sum notation also, just a little bit, and the table construction method. Okay, so why those three things is important to analyze the efficiency time. We'll look at some example, okay, afterward. Okay. Okay, so now we move to the direct observation method. What is the direct observation method? So in this method, we can observe the algorithm directly to get the approximation of time efficiency. Okay, so let's start with the example. So this is the example. So this is the example such as okay, so we have this one. So this function is to define the maximum element. Okay, find the maximum element. For instance, that you have the array size of n plus one. Sorry, this is n minus one. Sorry, it should be n minus one since this is n minus one. So 0, 1, 2, 3 until n minus one. So this is the size of A is n, and then need to find the maximum element. Okay, so then from this one. So first that we need to investigate what is the basic operations. Of course, that the question is explain what the goal of about algorithm. So the goal of in this algorithm is to find the maximum, right? So find the maximum number of in array. Okay, so that's it. So the second one, before we try to find the combinational time of the algorithm, it will be more easier if we know what is the basic operation of the algorithm. So look at here. If you want to find the maximum of uh, if this is 2, this is 3, for instance, if you want to find which one is the maximum, what do you do? You need the operation addition or additions or multiplications or something else. So of course that if we want to find the maximum, which one is the maximum or the minimum, for instance, so then of course that we have the comparison, right? So this one, so this comparison. So since that this comparison is the basic operation, so we can say that this is the basic operations. Sorry, basic operation. So this is the basic operation. So the basic operations is the in this case is the comparisons. So the comparison is the basic operation. So then after that we find that the basic operations. So after find the basic operations, then uh, we need to investigate how many basic operation will be executed in the loop. Okay, so look at here in this loop. So um, how many um, how many time the comparison in loop. So it is one, right? So this is one. This is one basic operations. Okay, so this is one basic operation. So then we have that this is one. So then finally we can write something like this. So since this is one, okay, so this is 1 second. So in this one will be executed in 1 second. Okay, so there's no other syntax, and then we'll move to the for. So the for that we in the loop that, so this is the different level. So when the different level, we write something like this. So from 1 to n minus 1. So how many times? For instance, from 1 to 2. So how many times? So it is 2 times. 2 times, right? So 1 to 3. How many times? 3 times. Okay. So from instance A to B, how many times? Okay, how many times? So it should be b minus a plus 1. Okay, so be something like this. Generally, from I equal 1 to n minus 1, so then we find that this is n minus 1 plus 1. It should be n minus 1. So then after we can find something like this. So since this is a different level, so this basic operation is in the side of 4, then we can define the tn. So the time is 1 times n minus 1. So the tn is n minus 1. Okay, so this is the direct observations. So now the next question is it possible that this algorithm, okay, can has best, worst, or average time, and why? So what do you think? So it is possible to have the worst or the best case or the average case? So the answer is no. Okay, so we don't have the average or the maximum or the minimum. So we only have the maximum. So actually we only have the maximum, since that this is not depend on. So this is not depends on something that it will be stopped. So this algorithm, this for this for is stoppable. Okay, stoppable from the inside. Okay, from the inside. So then this is not possible. It is not possible that this algorithm has average or maximum minimum of the time complexity. Okay. Okay. So now this example. Okay. Try to this example. So example that we have the function test end, something like this. So and we have basic operation. So what is the Tn? So that's the questions. Find the time efficiency. Okay. So what should we do? Okay. So first that we need to basic operation. So in here is a basic operation, for instance. So this is one basic operations. Okay. So there's no nothing in the same level. So we move to the next level. So the loop level. So the loop level in here is from 3 to n minus 1. So remember the formula is n minus 1 minus 3 plus 1. Okay. So n minus 1 minus 3 plus 1. So it should be equal to n minus 3, right? Okay, so it should be n minus 3. So then another level, so since this is another level, so that this is n minus 2 from 0 to n minus 2. So n minus 2, so n minus 2 minus 0 plus 1, so it should be n minus 1. Then finally, we have Tn. So the Tn is equal to, so since this is a different level, so since this is a level, so just we multiply. So this is 1 times n minus 3 times n minus 1, something like that. So this is n minus 3 n time n minus 1. Okay, something like this. Okay. Okay, so next example, something like this. So um so what is the uh, efficiency, time efficiency from the following algorithm? So what we can do? So this is very simple. So first that we look at the um the inner loop. Okay, so in this one, so this is the basic operation. So the basic operation, it should be 1 and this is should be 1. Since that this is the same level, so we need to plus 1. So this is 2, since this is the same level. And the fourth one is that in different level. So in different level from 4 to n, so this is n minus 4 plus 1, so it should be n minus 3. Okay. And since that the outside of this we have another basic operation, so this basic operation is same what we have is this basic operation same level at this 4, so it should be in a similar one. So this is 1. Okay. And then finally we have the outer loop. So the outer loop is from 20 from 1 to n, so it should be to n minus 1 plus 1, so it should be to n. Okay, so then finally we have Tn. So this is very simple. So the Tn is so since that this is 2 and this is we have different level with n minus 3, so that should be 2 times n minus 3. Okay, since that this one is same level at 1, so it should be plus 1. And since that all is inside of this loop, so this is all is time of 2n, since that different level. Okay, so it's in different levels, so it's in time. So that's this is the result. So the result is that we find that this is 4n squared minus 10n, which is in the big O of n squared. Okay, so this is actually very easy. Okay, okay, okay. Now next, so this is another questions. So please find that the time efficiency for the following algorithm. So this is find the unique element. Okay, so the first elements, sorry, for first uh, loop, we can see that there is dependence loop for I and for j. So we have, so they will be difficult. So when the loop is depend on, so the inner loop is depend on the outer loop. So using direct method maybe will be difficult. Okay, so then the easiest one that we need to use the another method which called sum notation method. Okay, so what is the sum notation method? We will focus on that. Okay, so before we talk about how to solve this algorithm, so first that we'll try to this example. Okay, for instance, we have the for I equal 1 to n minus 1. Do this is the operations. Okay, one operations. So what do we do? So we need to convert this one into sum notation. So this one is we need to write sum notation of I equal to 1 until n minus 1. Okay, and then in here is the operation, how many operation is executed. So in this one is 1, since this is the operation is 1, so it should be 1. Okay, so then after that we can continue. So this is the something like formula. This is something like formula b minus a plus 1. So n minus 1. So this is the above of the sum is n minus 1 minus 1. So this is the initial 1 plus 1. So it should be n minus 1. So this is very simple, the notations. Okay, so from this notation that we can generalize this notation into the operation of the sum. Okay, so something like this. So when we have the c as a constant and this one, so which a depend on I, so then c can be moved to the outside of the sum. Okay, and also this is the linear. So if the addition or the negative, so that we can divide into two, so something like this. And also something like this, so this is, for instance, this is a and this is b. It should be b minus a plus 1. Okay, something like this. Or something like the sum of this one, remember, I equal 1 and I, it is 1 plus 2 plus blah 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 plus n is equal to n time n plus 1 over 2. Okay, so then we go back to the previous algorithm. Okay, so from this one, so what we have, so first that this is um we now work from the outside of loop. Look at the outside of loop. Okay, so this is I equals 0 to n minus 2. So then what you need is to write sum of I equal to 0. Okay, so and this one it is n minus 2. Okay, now move to another loop. So in another loop, so we have sum again. Sum j is equal to I plus 1, and this one is n minus 1. Okay, and how many operations? So since that this is the operations, so this is the operations. So this is the operation is equal to 1, so this should be 1. That's it. So after you can find what the sum, how make the notation of the 4 into sum, and then finally you can find the tn. Okay, so tn is very simple. Okay, so this is very simple. So we have the previously something like this, I equal to 0 and n minus 2. It's sum of j equal to I plus 1 n minus 1 1. So what we can do is we first that we work at the inner. Okay, so remember that something like this one. So what we can see here that, remember that sum of, remember the previous one. So this is something like this, a b 1. So it should be b minus a plus 1. Okay, so in similar way, there should be n minus 1 minus I plus 1 plus 1. Okay, and we can use the basic algebra, and then we will find something like this: n minus 2 sum of I0 I equals 0, n minus 1 minus I. And then use this relations. So if a plus bi, so we can change to 2. Then we have this one, so we change about this one and this one. So then something like sigma of I equal to 0 and minus 2 and minus 1 is minus of sigma I, something like this. So remember that this one, so this one is equal to 1 plus 2 plus 3 blah blah blah. So we'll find something like this. Okay, and since that n minus 1 is the constant, since there is no I here, there's no I, so n minus 1 can be a constant, can be moved to the in front, and this one is become 1. Okay, so finally, yeah, finally this one will be something like this: n minus 1 square minus blah blah blah, and something like this. Okay, you can you can try by yourself to how to find this one. Okay, so I think that's all for presentation today for this week, week 8. Okay, so then we will move to the next weeks with the how to create table and etc. So we can find different algorithm how to find the time complexity with different algorithm. Okay, so this is the last example. So we'll try to solve another example next week in week 9. So but before that, we have a homework. So please try these homeworks. Okay, and please submit your homework in the LMS as usual. Okay, so I think that's all for today. Thank you very much for your attention. See you again in another video. Bye bye.